to the cloud. Good. So what we're going to look at tonight is simultaneous linear equations. We dealt with simple linear equations already. But when we talk about simultaneous equations, basically you're going to have what we call two or more equations with, well, in our case, let me not use the more, right? Let me go with two. Two equations with two unknowns, right? That's what we'll stick with, right? You have two equations with two unknowns. As you get into simultaneous equation, you'll figure out that you can have any number of equations, right? If you have three equations, you can very well have three unknowns. If you have five equations, you can have five unknowns. But we're going to stick with just two, right? Two equations with two unknowns. The reason why they call them linear equations is that, okay, let's take a pair, right? Let's say you have x plus y equal 5. Let's see, you got 2x plus, let's go with y again. Let's say you have that, right? Really and truly, this is a straight line, right? It's the equation of a straight line. For those who went to high school and probably they studied a little bit of what we call coordinate geometry, you will see that this equation, if you rearrange it, it looks like this. Y equal minus x plus 5, right? It resembles y equal mx plus c. See that? The y matches up the y. This is a minus 1 here, right? The minus y is the gradient of the equation. And well, of course, x matches up with the x, and 5 matches up with the c. 5 being the y-intercept, right? If you were to draw that on a graph, I think the equation is going to look something like this, like that, right? Here down here, it's 5, right? And the far out, and down here too will be 5 because the gradient is minus 1, right? Yeah. So these equations here are really straight lines. They're really straight lines. And that's why we refer to them as simultaneous linear equations, right? Later in the night, we're going to touch on simultaneous equations where one of them might not be linear, right? It might be a curve. We'll get to that, right? We're going to get to that. Good. So now that we understand what we're talking about, and why they call them simultaneous equations. Because when you finish solving and you get values for x and y, you will see that the solution is the solution to both equations at the same time, right? So whatever value you solve and you get for x and y must satisfy both equations at the same time. So you get an answer when you finish working out, and that's why you don't need a textbook to tell you you're right or the internet to tell you you're right. If you find x is a certain value and y is a certain value, you put them in these two equations, substitute them back here, and you will find that if you are correct, that those numbers that you find for x and y will satisfy both equations, right? So in other words, you have solved two equations at the same time, right? Hence the name simultaneous, right? You have done it at the same time. You have solved two equations at the same time, right? So you got why we call it linear. We're getting to understand, well, when you speak of simultaneous now, what you mean, right? And well, we want to know now, well, how do we solve simultaneous linear equations? All right. So there are plenty, except plenty, but there are many methods to solve simultaneous equations. You're going to hear about the method of elimination. Elimination. You're going to hear about substitution. And you're going to hear about a graphical approach. Then there's matrices, right? All these are methods of solving simultaneous equations, right? Um, tonight we're going to look at elimination and substitution. We're not going to touch on the graphical approach, and later in the course I may touch on, depending on how time and so goes. We're going to talk a little about matrices and how they can be used to solve simultaneous equations, right? And you will get to find out that matrices, there's a whole branch of mathematics that is built around matrices. And one of the very good uses of it is that you can use it to solve any number of simultaneous equations, any number of them, because of the very systematic approach that it makes use of. The arithmetic is very systematic, and it lends itself to programming, writing code. I will get to that. So let's talk about the method of elimination. Let's talk about the method of elimination. All right. So solving simultaneous. This is an M, right? Equations by elimination. Right? That's ION, right? Don't worry how I write. I hardly write properly these days. Too much of a hurry. So I just had one there just now. What did I have? I have what? Let's say you have to solve x plus y equal to 5. I think I had 2x plus y equal 8 or something like that. I had.
Correct,
Good.
sir.
Yeah, I think I had that, right? All right, good. So when you speak of elimination here, elimination, your whole intent is to get rid of either or eliminate either x or y, right? That's what you do. You try to eliminate either x or y, and then you solve for, if you eliminate, let's say you eliminate x, you solve for y. And when you find the value of y, you use one of these equations now to get, let's say x, right? If that's what you needed to get afterwards, right? So that's the whole idea. You eliminate one of the unknowns, right? You solve for the remaining one, and when you have gotten that value, you put it back in one of the equations to get the other one, right? I'll illustrate with a couple of examples. Good. So let's take this one. I don't like how I have this one, but I'll probably put it back like this. I'll put this one on top. I'll have x plus y equal 5, right? Good. Name this equation 1, name this equation 2. One of the things you got to do in elimination is decide what you want to eliminate, right? You decide that. Sometimes, instead of you deciding it, you look at the nature of the two equations and you can decide or let that tell you which one is best to eliminate, right? like, okay, you might want to eliminate x, right? Let's say you have in your mind, man, I'm going to eliminate x. However, the two equations could be of such that x is not the best one to try to eliminate. Like for example here, if I were to subtract these two equations, if I were to subtract it, right? You see, you get 2x minus x will give you x. Y minus this y will give you 0. 8 minus 5 is equals to 3. So very quickly, we got x. But if you had said, man, look, let me eliminate x, you would have had to go through a longer process, right? To eliminate x. These two equations were such that y was easy to eliminate because both of them had just y inside, right? So even though you might in your mind say, man, I like eliminating it, you know you like is what is very efficient to do, right? And in this case, the most efficient thing to do was to get rid of the y's very quickly because in both equations that plus y. So the simple thing was to do is just subtract, right? And we get x equal 3. And you don't even have to do any calculation. If x plus y equal 5 and x equal 3, right? Okay, so let's say we substitute x equal 3 in equation 2, right? Equation 2. Sometimes I don't say equation 2, I just put 2 in a circle, which means I'm substituting in equation 2. So you get 3 plus y equal 5, which implies that y equal 2, right? And you can try it in the both equations. So 3 and 2 equal 5. 2 by 3 is 6 plus 2 equal 8, right? So it works for both of them. So your answer, you want to write your answer somewhere. Answer, x equal 3, y equal 2. Right? Sometimes, as I said, you can decide what you want to eliminate. There are times when the nature of the equations can tell you, man, the best thing to eliminate is this one, right? So as you work many of these problems, you're going to get into whether you should decide or whether the equation should tell you what is easiest to eliminate, right? As you do more of them. Everybody get this one? This one is simple enough. I ain't getting no one. Okay, we got a sizable group now. We got about 13. All right. Good. Let's take another one. Let's take another one. Let's say you have to solve 3x plus y equal to 18. Maybe you have 2x minus y equal to 7. Let's say you have to solve that, right? And we're using elimination, right? Solve by elimination, right? Good. Again, you might say, man, let's say you're in the habit of eliminating x, right? That would call for a lot of work, right? What the equations are telling you is that, okay, you have positive y, you have minus y. So while in your mind you want to eliminate x, it's a bad idea. Because there is plus y and minus y, the simpler thing to do would be to add the two equations. And you get what? You get 5x. Plus y and minus y add to give you 0. And then you have what here? This is 25. So x then is equals to 25 over 5, which is 5. So the equations, the nature of the equations, kind of dictate what you should eliminate, right? So we got x equal 5, so we can, all right, let's call this equation 1, equation 2. And you can now figure out what y is. Maybe you can take Want to take the first one? All right. Substitute x equal 5 in equation 1 to find y, right? So you got 3 times 5 plus y equal 18. So what's this? 15 plus y equal 18. Well, that all of this implies that y equal 3, right? I guess um, you don't have to do anything. We're going to watch it and see that y has to be 3 for 15 plus y equal 18, right? So your answers, x equal 5, y equal 3. And you can put these numbers back maybe in this one too and see that it works, right? 2 5 is 10 minus 3 will give you 7. Follow this one? Let's do one where you can decide what you want to eliminate. And the equations sometimes don't give you a clear indication of, what is very efficient to eliminate, right? Let me do one like that. So let's say you have to solve, all right, solve by elimination, right? 5x plus 3y equal 21. You got 2x plus 7y equal, okay, 20. So here, there is no, when you watch these here, there's no easy and quick fix. Maybe I can add the two equations and something will be eliminated, or subtract the two equations and I'll get rid of x or y. No. If I add, it doesn't help anything. If I subtract, it doesn't help anything, right? So in this case, you will have to decide, well, what is it I want to eliminate, right? So you want to decide what you want to eliminate. You tell me. Do you want to eliminate y? Or do you want to eliminate x? I ain't hearing nobody.
Sir,
Hello?
let's go with y.
Eliminate y.
Oh, you want to get rid of y. So good. So to do that, there's a neat trick that is used in doing that works for any pair of equations, right? There's a neat trick. And look at the trick. If you want to eliminate y, this is what you do. Multiply this equation by the coefficient of y here, multiplied by 7. And then multiply this equation by the coefficient of y in this one, sorry. So, right, multiplied by 3. So if you want to eliminate y, you simply multiply the first equation by the coefficient of y in the second, and you multiply the second equation by the coefficient of y in the first, right? And look at that neat trick, what it does, right? So we get now 35x plus 21y. Oh gosh, somebody help me with this. 717, 72 is 14, 147. So there's some ugly numbers there. Multiply everything by 3 here, I'll get 6x plus 21y. Notice that equal to 60. You notice what happened there? This neat trick of kind of multiplying the two equations by the coefficient in the other one, right? So you take the first one, multiply by the coefficient of y in the second one, take the second one, multiply by the coefficient of y in the first one, and look at what happens to the y. Both of them has the same coefficient, right? And that's a trick. If you can remember it, you're okay. And now we can do the subtraction. If we subtract, look at what happens. So 6 from 39 will give you what? Sorry, 6 from 35, right? You'll get 29x. this 21y minus 21y will give you 0. And what's this? 0 from 7. How much you get here? 87, right? So this tells you that x then will be 87 over 29, sorry, 29, which is equals to 3, right? So we got x equal 3. So we want y now, right? So we can substitute in any one equation. Substitute in this one, that one, that one, that one, anyway, right? I'll choose this one with the smaller numbers, right? I shouldn't say smaller because 7 is still big. Good. So what I'll do now, move it aside a little. So substitute x equal 3 in, all right, let me call this one equation 1, right? In equation 1. So I have 5 3's plus 3y. Oh gosh, I said I'll substitute the second one. I end up doing it in the first one. All right, no problem. Equal 21, right? So 15 plus 3y equal 21, right? Take this over there, you will get 3y equal 21 minus 15 is 6. Is that right? Yeah, right? Going up here, which implies that y equal 6 upon 3, which is y equal 2, right? So those are your answers there. So we got x equal 3, y equal 2, right? And you can try them in any one of the equations and see if it will work. So back to what I was telling you, right? You have to decide when you have these equations where sometimes you don't have like, okay, the coefficient of x in both of these equations is the same, or the coefficient of y is the same, right? You have all kinds of numbers. This neat trick always works, right? It always works. Let's maybe do one last one that, as I said, okay, well, I didn't say it before. We can't touch on all the types, right, of equations that they could bring that involve simultaneous equations, right? The kinds of problems that you will encounter is enormous, right? I can't touch on every one of them, but using your knowledge of algebra that you have learned over the weeks, you can be able to handle most of them, right? Let me show you one that, all right, let's say you have to solve. Look at something like this. Solve by elimination, right? You have this ugly one. 3x minus 5 equal to minus 16. All right, look at this one. 2/3 x plus 4 over 5y equals 6. Look at this one. Horrible, horrible, right? But yet, it's doable. It's doable. You learned about, I think we covered algebraic fractions. Remember that? Right? We dealt with that. So it's doable, right? So what we could do, all right, let's call this equation 1, call this equation 2. Right away, you see that, you know what? Oh, this is supposed to be 5y. 5y. Yeah, minus 5y. Yeah. You see that equation 2 needs some work, right? You need to get rid of these fractions, right? So one of the best things you might want to do is probably multiply throughout by the LCM of 3 and 5. You see that, right? So maybe what we could do We're not going straight to elimination and all of that. We have to do some preparatory work, have to simplify one of the equations to make it look like the first one, nice and linear. So this is linear, but it's just, riddled with fractions all over. So let's say we multiply everything by 15, right? LCM being 15. So you multiply everything by 15, you'll get what? 15 is the LCM, right? 15. How will we get here? 15 by 2/3. All right, let me write it out just in case. Plus 15 by 4/5 plus the 15 by 6, right? And what will we get here? 3 ones, 3 fives, okay. 5 1, 5 threes, all right, what? That'll be 10x. This one will be 12x. Sorry, 12y. What will this be? 6, 9. Okay, so we get that? 10x plus 12y equal 90. Good. So now we have something, well, it doesn't look so bad, right? No fractions. Let's call this equation 3. All right? Let's call it equation 3. Good. So we got some equations that we can work on. Let's say we want to let's put equation 3 on top here. 90. And then we can put back equation 1 here. 3x right? Good. So again, now we have to make the decision. What do we want to eliminate? And maybe I'll throw that to you. You want us to eliminate X or Y?
X or
Okay, you want to eliminate X in this case. All right, good. Because I think the last one we eliminated Y, right? I think so. So,
correct.
All right, let's do that. So what we'll do now, we'll multiply this one, and then we're gonna apply that trick that we learned in the last example, right? So we said we want to eliminate X. So what we'll do, multiply this one by 3 and multiply this one by 10, right? And let's see what happens. So I'll move this aside, right? And we'll get what? We'll get 30x plus 36y equal to, what's that, 180? No, 3 9 is 12. What am I doing, man? Hey, these late classes are messing with my mind. 3 9 is 27, 270. Again, we'll have 30x here. Minus 50y is equals to negative 16 by 10 is what? Minus 160, right? Good. So we have these two now. What we could do is now subtract, right? When we subtract, the two x's will go. And 36y minus 50y will be what? You're basically adding them, right? And the 2 minus will become a plus. So you get what? 86y equal to 270 minus 160 will give me what? 7630, which is about 430. Right? Big numbers. You don't like them, but you got to deal with them. What can you do? So this means that y will be equal to 430 over 86, which is, punch it in a calculator there. Somebody is helping me. You helping me? Hmm? Nobody helping me. Like 5?
Sir, it's not 344.
3, 5, 4. Where?
It's not 430 divided by 86.
When you get 5?
Sorry, I get 5.
Yeah, you're fine. Calculator will do it for you.
Yes, sir, I get 5. I plus or something I do.
All right, good. So now we can substitute. We can substitute y equal 5 in equation 1, right? I think what was equation 1? Equation 1 was 3x minus 5y equal minus 16, right? And equation 1. So what is that? I got bumped off for some reason. Tell me if you can see back my screen. I got bumped off just now.
I
So
can see it.
is your day to
All right. So we're gonna get what? Um, so you'll get 3x, and I bring the 25 over there. You have 25 minus 16. 3x is equals to 9, right? Which that's not hard. X equal 3, right? If 3x is 9. So we got our two answers there. X equal 3, y equal 5. Right? So as I said, elimination can come in a lot of forms. But we're going to stick with this for now. Good. So that's a little bit on elimination there. Our next method that we'll deal with is the method of substitution, right? Method of substitution. The method of substitution, it doesn't work very well. I mean, I say it can work. It can work with all those that we did there just now. But lots of times it might involve a lot of fractions that is very difficult to handle. So substitution tend to work. Let me show you in what types of equation. Right? Let me give you some examples. Let's say you have to solve 5x look at this. Now, let me show you what substitution really involves. So let's call this equation 1. Let's call this equation 2. You note that in this equation here, you have a y here, right? You have a y here, a lone y. So from this equation, from equation 2, y will be equal to 12 minus 2x. See if you see that. If I take this 2x over here, I get 12 minus 2x. So I got a value for y. I'll call this equation 3. You see that? Do you see that? That from this equation, I can get that y equal 12 minus 2x. Tell me if you're seeing that. I simply take the 2x over the other side in equation 2. Right? I took this one and I make y the subject. I brought 2x over here. This is what you get. Right? So what I'm going to do, I'm going to take this 12 minus 2x because that is y. And I'll put it in the first equation where I see y, right? So I'm going to substitute 12 minus 2x for y in equation 1. And look at what we'll end up with. So I have 5x plus 3 bracket. I'm going to write 12 minus 2x, right? Because that's y. That is y, right? Y is 12 minus 2x. So where I see this y, I'm putting 12 minus 2x, all equal 31. Now what you see here, there's no y now. You have an equation that is all x, which turns out to be basically what we will call a simple equation, right? We'll call that a simple equation, and we can take that now, and with our knowledge of simple equation, we can write that as 5x, okay, plus 3 by 12. We're removing the bracket now, right? 36 minus 3 2s is what, 6x equal 31, right? And then we can do what here? We can, okay, have 36, 5x minus 6x will give us minus x equal 31, right? And then we can probably take this over here and bring this over here. You have 36 minus 31 equal x, right? So x is equals to 5. So we got x there, right? Again now, since we find x, we can now get y because y is equals to 12 minus 2x. So substitute x equals 5 in, you can do it in any equation, but this is very simple, equation 3. In equation 3, and look at what we get. Y will be equal to 12 minus 2 times 5. Y is equals to 2. So our answers, x equals 5, y equals 2. Right? So that's what substitution is about. You're looking for, where you have maybe one of the unknowns by itself. The coefficient is 1. So we can take it and make that the subject, as you see here. I make y the subject because it's alone, right? And you now get y in terms of x. You take that now and you substitute it in the other equation. And the effect is that you basically eliminate all the y's. There's no y to deal with. We now have a simple equation as you see here, right? And, well, we're able to solve that because we know how to solve simple equations from a couple weeks ago. Right? You follow this one? Is this one hard? Not getting any feedback.
Sir, can you please go over it?
Or we just need more practice.
Yes, I think that's what's happening.
Sir, can you please
Yeah.
go over it for me?
All right. Yeah. All right. So as I was saying, substitution doesn't work very well, especially when you have all kinds of numbers. Like if I put a 3 here, or let me put a 4 here, a 4 here. Forget substitution. Don't ever attempt to do substitution when you see that happening, right? Substitution works well when you have maybe just a y or maybe an x alone. Don't write up on the screen because I can't erase that. Only you can erase that. Right? So in this case, I see a y alone, right? I see a y alone. So what I'll do is I'll make that y the subject of this equation, right? I'll make that y, and that's what I did here. So I get y equal 12 minus 2x, right? I'll call that equation 3. Now, since, remember the y in here and the y there is the same y. They have the same value, right? So I can now write 12 minus 2x. I can put that in the place of this y. And that's what I'm doing here. I'm putting 12 minus 2x in the place of y in the force equation, right? So force equation is 5x, it'll be 5x, plus 3y. Well, remember, y is now 12 minus 2x. So I'm putting it there, right? Equal 41. So we got everything right there, right? What you notice now, there's no y to deal with. You have an equation with only x inside. It's basically what we call a simple equation, right? So you can just, remove the bracket and simplify, and so as you see here, right? And you solve how you would normally solve a simple equation, right? So when you solve this, we get x equal 5. Now that we know x, we can further substitute now. We can substitute x equal 5. We can do it in any equation. We can do it there, we can do it there. I just choose to do it in this third one because you can get y directly there, right? So I substitute in equation 3, and that's what I'm doing here. And I get y equal 2. So I've been able to find x and y through substitution.
Okay, sir.
Let's do another one. Let's do another one. Come
Please
clear.
don't remove that as yet.
Okay, the more you watch these, right, and you watch examples being done, and then no matter what, right, no matter how much examples you watch, you have to try one of your own, right? You need to try a couple of your own, and then you're able to get a knack of it, you know? Tell me when you're finished.
Finish, sir.
Good. Let's take another one. Let's say you have to solve by substitution, right? You get 2x plus y equals 7. Get 3x minus 2y equals 7. Right? So here you have two equations. Let's name them. Call this equation 1. Call this equation 2. And here you see again, you see a lone y. Right? You see a lone y. So a good thing to do then is, you know what? Make y the subject. So from equation 1, y will be equal to 7 minus 2x. Why does this resemble the first one? So we got from equation 1, y equal to 7 minus 2x. We can probably call this equation 3. So now that we got y, we can put that y in the place of this y here in equation 2, right? So substitute, and that's what I call in the method of substitution. Substitute 7 minus 2x for y in equation 2. Right? And let's see what we get. So we get 3x minus 2 times, and y is now this, right? 7 minus 2x. All of that equals 7. And what we basically have here is a simple equation again, right? We have a simple equation. And we can now simplify that. We'll get 3x minus 2 by 7 minus 14 minus 2 by 2x minus 2 is 4x equal to 7, right? So we'll get what there? we'll get 7x minus 14 equals 7. Bring that over there. 7x equal 7 plus 14, 7x equal 21. X then equal 21 over 7 equal 3. Right? This is a no-brainer. You're supposed to know this, right? So we got x. To find y, you know, because we have to find y, we can use equation 3 again, right? So substitute x equal 3 in equation 3, right? And that's what I'm going to do. Y will be equal to 7 minus 2 by 3. So you get, what's that? 1. So your answers x equal 3, y equal 1. Right? That's what substitution is about. But remember, it only will work. It can work when you have all kinds of numbers. Maybe if I put another number here, 3 or 4 away, it can work, but it will involve so much fractions that it's going to be very tedious to do. So substitution is better used when you have like maybe just a y or an x, you know, in one of the equations, just 1x or 1y. If not, avoid it. Avoid it. Good. So what we're going to do next, and I'm going to pause a little, give you a little break and so. When we come back, we're going to use more substitution. But in that case, we're going to have equations where one of the equation is linear, one is nonlinear, right? You'll see what I'm talking about. And you might end up with a quadratic and so, right? And you'll see how we can solve that. So let's do a pause here. Take a little break. Good. Let me start back the recording. Yeah. So we're going to look at simultaneous equations where both are not linear, right? So here you have a linear equation. Here you have a nonlinear equation, right? So here is where the method of substitution is very valuable. Because look at what we can do now. We can take, all right, let's call this one equation 1. We'll call this one equation 2. And we can take, okay, let's take this one. So from equation 1, we can get what? We can get y equal 5 minus x, right? And we can probably call that equation 3 if we want. And now we can take this value of y, 5 minus x, and put it in the place of y here. So we end up with x times, remember y is now 5 minus x. 5 minus x equal to 6. Right? And let's see what happens to that now. Take this now, you end up with 5x minus x squared equal to 6. Right? If you take everything to this side, you can probably end up with, get x squared minus 5x plus 6 equals 0, right? I don't know if you see what I did there. Let me do it. I'm taking everything here over here, right? So it's like 0 here. But I'm not going to write it like this. I'm going to write it as x squared minus 5x plus 6 equals 0. Right? Good. So now we have a quadratic. We have a quadratic there, right? So we're going to solve this quadratic. And we can factorize. We can factorize it, right? Let's see, two numbers, P and Q. when we add them must give you -5, and when you multiply them, you must get +6. Well, you can see those numbers, right? -3, -2, when you add them, you'll get that, when you multiply, you get that. So we end up with x squared minus 3x minus 2x plus 6 equals 0, right? We rewrite this one using the -3 and the -2. And from this now, okay, group those two, group these two. Remember, you have to change this sign in here, right? I hope you're remembering all of this. So here you factorize out x minus 3, down here 2. This is common, you put it to the front. Put x minus 2 in the next bracket. So, oh, you know, to do the process, what is it? Either x minus 3 equals 0, which implies that x equals 3, or x minus 2 equals 0, which implies that x equals 2. So we got two values for x. We got 3 and we got 2. But remember, y is equals to, what was it? 5 minus x? What was that it? Yeah, y is equals to 5 minus x, right?
Yes, sir.
So substitute x equal 3, right? You get y equal 5 minus 3, which is 2. Next, substitute x equal 2. So y will be equal to 5 minus 2 equal 3. So your answers are either x equal 2, y equal 3, or x equal 3, y equal 2. Right? So those are your two solutions.
Sir, can you please pull back the screen
How
a
far?
little more?
So this is the
Yes.
beginning, right? This is the
It
beginning.
is a lot to digest.
Yes. So you're making use of substitution. So these are the two original equations,
Yes.
right? I took this first one and I make y the subject. So you get y equal 5 minus x. So I substitute this 5 minus x in the place of y there in the second equation. That's what I'm doing here. You get
Okay.
x times, well, this is y, all equals 6. I remove the bracket, you get this? I bring all of this over here. So the sign on the 5x is going to become minus. The sign on the x squared is going to become plus. I put it there. And I write it back like this. I don't like looking, you know, 0 here. I put it back like this. So I have a
Yeah.
quadratic here, which I can solve by factorization. Not all times. Not all times you can solve by factorization. When you can't, well, I'll show you the formula in just a moment. I'll show you later on in the lesson, maybe towards the end. I want to confuse you. So I solve this here by factorization. And that's what I'm doing here, right? This is what I'm doing here. Solve all of that. And I get x equal 3, x equal 2. I need to find the corresponding y values now, right? And that's what I'm doing here. I know y is equal to 5 minus x. So we use x equal 3. I find a corresponding y value of 2. Next, I substitute x equal 2. I find a corresponding y value of 3. So these are all my solutions. Either x equal 2 and y equal 3, or x equal 3, y equal 2.
Okay, sir. Please pull the screen down a little bit.
Done.
Yes. Thank you.
Could we do another one now?
Yes, no, sir. Pull back the screen a little. Let me just flash it and I will just allow you to go move ahead. Yes. Yes, you can move ahead. Yeah, thank you. Better. Thank you.
Good. Let's take another one. Let's say we have to solve R. Let me make it back bigger. So we have to solve x squared plus y squared equal 5. Sorry, 25. And x plus y equal 5. Right? So here, this is basically a curve, right? Equation 1, this is a curve. It's a circle, in fact. And this one is a straight line. Right? Equation 2 is a straight line. 1 is a circle, 1 is a straight line. Basically, what you're trying to do is find where the line intersects the circle. I'll show you on a diagram just now. Right? I'll show you both of them, the solution. I'll show you them on a graph. Good. So how do you solve this? Again, you make use of substitution. You take from equation 2, you can see that y would be equal to 5 minus x, right? So you take this now, substitute 5 minus x for y in equation 1. So you have, okay, x squared plus 5 minus x, because that's y now, square, equal 25. Right? So now we have basically a quadratic here to solve, right? So let's do that. So we're going to remove the bracket here, right? What will we get? We'll get x squared plus, all right, this means this, 5 minus x times 5 minus x, right? Equal 25, right? So we're going to expand it up there. I'll put back x squared there. I'm going to expand this now. 5 by 5, right? That's this 5 by this 5, 25. Right? 5 by minus x will give you minus 5x. This minus x by 5 will give you another minus 5x. And then this minus x by this minus x gives us, oh my, what am I doing? Positive x squared, right? Equal to, what is it, 25? 25, right? Wait, something is in the way here. 25, right? Good. Let's simplify and see what we'll get. So this x squared and this x squared, 2x squared. What's going to happen there? Minus 10x plus 25 equal to 25. Okay, so what will happen there? So then you have 2x squared minus 10x plus 25 minus 25 equals 0. This is nice. So you end up with 2x squared minus 10x equal to 0, which is easy. So you get, okay, 2x into x minus 5 equals 0. Is that what's happening there? Yeah. So either 2x equals 0, which implies that x equals 0, or x minus 5 equals 0, which implies that x equals 5. So we got two numbers. We got x equals 0, x equals 5. Let's see what we can do with that. So we know that y equal, what was y equal to? 5 minus x, right? 5 minus x. So substitute x equals 0. Y then will be equal to 5 minus 0 equal to 5. Next, substitute x equals 5. Y then will be equal to 5 minus 5 equals 0. So your solution, either x equals 0, y equals 5, or what was it? X equals 5, y equals 0.
Or
Huh?
the thing hurt in my head.
Yeah. That's the whole idea.
Are you alone, sweetheart?
Sir,
Yeah.
I get a headache right now. I need some tablets.
All right. This is the end of it. Yeah. Right? And just to show you what these look like on a graph. Oh, in case my friend is writing, let me put everything. Yeah, so you can see everything one time.
Third, on
So
the
it's
X, get W, K or T, WKT, or what is written
we
there?
know that. We know that. We know that.
We know that. Oh,
Yeah, we
thanks.
know that y equals 5. Right? Yeah. The little thing
Thank
they
you.
use in some math textbooks and so. That's
You can,
taking you to a higher level here, you know?
okay, thank you. You can clear your board.
Yeah.
No,
So what
sir,
this
that
will look
no.
like, I'm leaving it for a moment. Yeah.
Yes, sir, I can continue.
1 minute, sir.
Substitution between your legs.
Mhm.
Thank you.
Yeah.
With this linear equation.
As I was saying just now, these really represent this x squared plus y squared equal 25 and x plus y equal 5. They're really, one is a circle, one is a line. I'll just show you these solutions. X equals 0, y equals 5, x equals 5, y equals 0 on a graph, right? So I'll stop sharing for a moment, and then I'll share back. I'll share back my one moment. So remember I told you, okay, before you tell me if you're seeing there.
Yes,
Yeah.
sir.
Good. Remember I told you that the first one was what? X plus y equal 5. And I told it was a straight line. And then I had what? XY equals 6, right? X plus Y equals 5. Yeah. So
Yes,
this
sir.
is what it
Correct.
looked like, right? Yeah. And where the line intersect was 2 and 3 or 3 and 2, right? Those were the solutions. X equal 2, Y equal 3, or X equal 3, Y equal 2. It's where the line and the curve intersect. I'll show you the other one in just a moment. So we had X plus Y equal 5, that was the line. And then down here, we had, what was it? X square, X square plus Y square equal, what was it? 25, right? And that's what it looks like. So this is your solution 0, 5, or 5, 0, right? X is 0, Y is 5, or X is 5, Y is 0, right?
Okay.
Yeah. I just wanted to show you how, the
Came up with one.
mathematics, yes. I think we had some earlier. I just want to show you maybe, give me a pair of equations that we solved earlier. Two
We
linear
did
equations that we solved.
2x, 2x plus y equals 7.
Okay.
And the other one is 3x minus 2y equals 7.
3x minus 2y.
Equals 7.
Okay, good. And that's your solution here, right? X equal 3, y equal 1. See, so they represent lines. That's why they call them linear equations, right? So
Okay.
this here, that's the solution. Good. So I'm going to stop sharing here for a moment again. And I just want to cover one last thing. I think I did this before, but for some reason, I can't clearly remember. Right? I can't clearly remember. So I'll just cover it back quickly. That if you have a quadratic equation of the form ax squared plus bx plus c equals 0, then x is equals to minus b plus or minus the root of b squared minus 4ac all over 2a. Did I ever give you this?
I don't think so.
Yeah. Let me check.
I think so, man.
I
Yes,
believe
Yeah,
sir.
I
Yes,
started
sir.
class
You
late,
did
sir.
give us that.
Started class
Yes.
late, so
So,
that's
so
why.
if you
yes,
have
you
an
did give us
equation,
that.
if you
Sir,
have an
you showed us
equation that,
that, but you
Sorry about
didn't
that.
do a workout with it.
okay,
I'm
okay. So
trying to
I'll
remember one
probably
of the
do one
days.
or so. I'll do one or so,
I'm trying to see.
right? So let's say you have an equation that you know, you're not sure, or maybe you try factorizing it and it's not working out, right? It's not
Sir, we
working
did it
out.
on the 7th of October.
Oh, look at that. Somebody know the date. Yeah. So let's say you have an equation,
That
right?
was not a part of the class.
Let's say you have an equation to solve. Solve. Let's I can't think of an ugly equation now. Let me just give you one. X squared plus 3x minus 1 equals 0. Right? So I don't think this one can factorize. I can't think of two numbers when you add them, you get 3. And you multiply and get minus 1. I don't think so. Right? So what you want to do is liken it to this here, right? So A is like 1, B is like 3, C is minus 1. Right? And you substitute in here. X is equals to minus B, which is going to be minus 3, plus or minus the root of 3 squared minus 4 times A times minus 1. And all of that, I'm going to come up here now, right? I'm going to get minus 3 plus or minus the root of what all of this will be. This is 9. 9 plus 4, will that be? 9 and 4 is what, 13? All over, oh, I left out all over 2 times 1, right? Which is all over 2, right? So your X values are going to be minus 3, we're going to use the plus root 13 over 2. And you can work that out now in a calculator, right? Can somebody help me? I don't have a calculator with me nearby. Square root of 13, take away a 3 from it, and then divide it by 2. Tell me what you get. I don't have a calculator near me, so help me with it.
2.5.
Take square root of 13 first, then subtract 3. And the answer you get, then divide by 2.
Sir, I get where is it? I get 3.39. I don't know.
3.39, all right.
Yeah. There's the
Anybody
square
else
root
get
of
something else?
13. Subtract 3 divided by 2, right?
Yeah, you have to be cautious. Square root of 13 is how much?
No, sir, I'm asking the square root of 13. Subtract 3 divided by 2.
Yeah.
Okay, yeah, that's what I get. I put it again and see.
Watch. When you find square root of 13, right?
Mm-hmm.
When you subtract the 3, press equal, then divide by 2.
Okay. Okay, sir. Let me do it. Square root of 13.
What is square root of 13, by the way? It's going to be around 3 point something, right? No, this
Yeah.
answer can't write. This answer can't write. They're wrong.
Just now, sir. Let me check it back.
Square root of 13 is around 3. If you take away 3 from some number around 3, you get a number less than 1. 1 divided by 2, you can't get that. That's wrong. You almost be conscious on sizes of numbers.
Sir, when I did the square root of 13 times 3, I get 3.16.
Stop it. What are you saying? Square root of 13 is how much?
No, when I square root the 13 and the 3 minus the
No,
3.
no. Do one at a time. You can't, clearly you can't handle that calculator properly. What's the square
No,
root
sir,
of
I'm doing
13?
it on my phone. That's the
Work
thing. I
it.
don't.
What's the
Okay,
square
well,
root of
see?
13? What's the square root of 13? So this class got about 30 something people. I hope everybody is trying the thing.
Three point
Look,
6055.
good. So if you
Continue.
get 3.6 something, when you subtract 3 from that, you're supposed to get 0.6 something over. Well, now you're going to put it over 2. So this answer wrong, man. Nobody else is trying it? Oh, hell.
Hold on, sir. The square root of 13 will be 3.6.
Sir, when
Good,
you
well,
subtract
subtract
the
3 from
2,
it.
you get 0.60.
Then
Good, and
subtract
divide that
3
by 2 now. Divide it
and
by 2
divide it by
now.
2.
2.10.
You can't get 2.10. What crazy is it? 0.6
0.302.
Sorry.
0.3
Very slow.
0.302.
2.1.
or 0.3,
Yeah.
right? Good. Or, remember, we use minus 3 plus that, right? Or x equal minus 3 minus root 13 all over 2 now. What will you get now? So what you're going to do here, don't worry the minus sign. Find the square root of 13, add it to 3, and keep the minus sign. Tell me what you'll get. You'll get 6 point something. 6.6 something over 2, right? 6 point something there.
6.60.
Good. Divide by 2 now. Now you get what? 3.3
Yeah, 3
minus,
point.
right? Minus. Good. So your answers are answer x equal 0.3 or negative 3.3. Right? So this is using that formula.
Please zoom out a little bit, sir. Thank you.
Yeah. Right? So that's using the formula. So if you're in a corner where you're not getting the thing out by substitution, sorry, by factorization, fall back on the formula. Fall back on the formula. Good. I think that's enough for one night. All right. I'll try to make the recording available to you sometime during the week.
So, any update on the test scoring?
I didn't give you all about the test score.
I didn't